Hey, geometry people. This week we're going to talk about word problems with right triangles. So last week and the week before, we've been talking about just in general how to solve right triangles if you're just given a right triangle, using sine, cosine, and tangent to be able to find missing sides and angles. So today we're going to look at what happens when you're given word problems that would involve right triangles and using sine, cosine, and tangent still. So the first thing that we need to talk about when we talk about these kinds of problems are the word angle of elevation and angle of depression. Um, so a lot of times this is best illustrated when you're thinking about a problem involving an airplane. So for this unit, you'll get to see a lot of my lovely drawings. Here's our airplane. So if we're talking about an angle of depression, it's talking about this angle here. Like if you've got a little dude away on the ground over here, if we're talking about the angle of depression from the airplane to the guy, this would be our angle of depression. So it's an angle looking down. If we're talking about angle of elevation, we would be talking about the angle from the guy looking up at the airplane. So if a guy's looking up at the airplane, that's his angle of elevation. Okay. So an easy trick, though, for all of these kinds of problems, you're going to end up drawing right triangles a lot, right? Whatever it says, angle of depression, angle of elevation, put it in the bottom corner. The reason being that his horizon line and the plane's horizon line up here, they're parallel. So your angle of depression and your angle of elevation are going to be the same here. So however you draw it, putting it inside your triangle and putting the angle in the bottom corner is usually a good idea. So with that, let's talk about some of the kinds of problems that we will see involving angles of elevation and depression. The nice thing about these kinds of story problems is that they're often more interesting to read. The difficult thing about these kinds of story problems is they don't always come with a picture. So if it doesn't come with a picture, draw a picture. Your picture can be terrible, it can have stick figures, it can have just a triangle with the corners labeled as to what the locations are. Doesn't matter as long as you draw a picture and label it, because that will definitely help you when it comes to putting the different parts in the right places. So anyway, let's say for this first problem we have a snowboarder and he's at the top of the mountain, and a lot of my mountains and things like that are going to look like triangles. So we have a right triangle. Here's our snowboarder at the top of the mountain. And he wants to know how far it's going to be to get down to the lodge. He knows that he's 1,000 feet up vertically. That's his elevation. So whenever they talk about elevation, that's usually the vertical side. Just a heads up. He knows he's 1,000 feet up, and he knows the angle of elevation from the lodge to him is 35 degrees. And he wants to know how far he has to snowboard before he gets to the lodge. So that's the side we're missing, the side that's between him and the lodge. Okay, so now we've got our right triangle problem that we're used to seeing, right? We're solving for a missing side. So all we have to do is set this up. So we're given this angle right here. So now we go about labeling our sides. 1,000 feet is the opposite side to the angle that we know. X, the side we're missing, is the hypotenuse since it's across from the right angle. So opposite and hypotenuse, that means we're using sine, since sine is opposite over hypotenuse. So if it helps you right away, write down what sine, cosine, and tangent are on your paper. So anyways, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You might want to have those written down somewhere before you start these problems. But anyway, Setting this one up, we have sine of 35 degrees equals opposite over hypotenuse, so 1,000 over x. Okay, so now all we have to do is solve this. So to solve, first we get rid of the denominator, so we're going to multiply by both sides, or on both sides, by x. So now we have x sine 35 equals 1,000. Then we want to divide by sine of 35 on both sides to get x by itself. Sine of 35 cancels here. I can type this into my calculator. First thing you want to do with your calculator, make sure it's in the correct mode. Make sure it's in degree mode. So then we go 1,000 divided by sine 35, enter. And we get 1,743.4. So that is how many feet he has to snowboard to get from the top of the mountain to the lodge. All right. So that's one kind of problem that you might see, solving for a missing side. The second kind of problem that you might see is going to be solving for a missing angle. Okay. So for the solving for a missing angle problem, we're going to say that you are hiking up to a lake. And let's say you know that your hike is 15,025 feet that you're going to spend hiking, and that you're going to gain 2,000 vertical feet. So if you're gaining elevation, if you're gaining, vertical feet, that's going to go on the vertical side. If it's the length of your hike that they're talking about, then it's going to be the distance that you would actually walk. If they said just the horizontal distance, or really if horizontal is mentioned at all, that's typically this horizontal side. So just some words that can kind of give us a red flag as to where they're supposed to go. Anyway, and they want to know, and you're smiling because you're hiking, they want to know what your angle of elevation is. So the angle of elevation from you up to the lake would be this angle down in the bottom corner. And it's always a good idea to use that bottom corner angle. Okay, here we go. So this is going to be one of our inverse problems, right? We're going to have to use inverse sine, cosine, or tangent in order to help us find our missing angle. So first thing we do, we take our missing angle and we label the sides. So this is the opposite side, and this is the adjacent side. Or not adjacent, gosh. Losing it. All right, not the adjacent side. This is the hypotenuse. I was thinking that I should have done a problem using the adjacent side, but I didn't. Oh well. Because this one is going to use sine again. Because we have opposite and hypotenuse. So sine of our missing angle x equals opposite over hypotenuse. So 2,000 over 15,025. So then what we need to do in order to find x by itself is take the inverse sine of both sides. So x is going to be sine inverse of 2,000 over 15,025. Then we just type this into our calculator. Usually it's a secondary function, so you have to hit second sine 2,000 divided by 15,025. And we get 7.65 about degrees. So that would be our angle of elevation that we're hiking at, 7.65 degrees. Okay, so hopefully this was helpful. If you have any questions, comment below, come to office hours, or send me an email. Have a great day.